Hariom. In this session we discuss a new property called capillarity or capillary action. What is meant by capillary? Capillary means hair-like. Means a tube with a very fine hole is called a capillary tube. Hair-like thickness for the hole. Such a tube is called capillary tube. Now, when you dip that kind of a tube into a liquid taken in a beaker, suppose this is the liquid, and if I am dipping the tube into the liquid, we can find that the liquid will be rising up through that tube to a certain height. The liquid is rising through the tube. Okay. Now this rising of the liquid is called capillary action. And in some other liquid you can find that, see, suppose I take mercury. That mercury taken in a beaker will be having its surface like this. And if I dip the tube into that liquid, we can find that the mercury level inside will be going into the tube. Means the mercury will be getting depressed in the tube. Now here is also the action is called capillarity. Now in this case the liquid is found to go deep into, and it is because of the property of the liquid taken along with the capillary tube. Now to study more about this capillary action, we must understand a quantity called angle of contact. Angle of contact. Now angle of contact will be defined. It is the angle made at the point of contact of the liquid with the solid. For example, this is a point where you can define angle of contact. Here is another, like that. Wherever the liquid comes in contact with the solid, you can define the angle of contact. Now, how we define it? Let's see. If I take the tangent at the point of contact, it goes like this. And I take the angle between the tangent and the surface of the solid inside the liquid. So this can be the angle of contact here. Okay? And you can see this is the angle of contact here, and see this one, tangent, this can be the angle, and here tangent, this can be the angle of contact. Like that you can define the angle of contact in this case. And here you can see the tangent goes like this, liquid surface, and this will be the angle of contact here. Like that here you can see this is the angle of contact. So angle of contact can be defined as the angle made by the tangent drawn at the point of contact of the liquid surface and the surface of the solid inside the liquid. See, surface of the solid inside the liquid. Understood? So this is what we call angle of contact. Now this angle of contact is found to depend on the type of liquid and the type of solid, and also on the medium surrounding that place. Here is air we have taken. So for a given solid and a given liquid, with a particular surrounding, will be having a constant angle of contact. That won't be changing. Even if you tilt that position and all, no problem, the angle of contact will be the same. But if you add impurity to the liquid, the addition of impurity will be decreasing the angle of contact. And another thing, if you heat up the liquid, if you heat that liquid, we can find that the angle of contact is found to increase. So, these are some of the points to be noted. Another thing, here we can see the angle of contact is acute angle, that is angle theta is less than 90 degree. And when the angle of contact is less than 90 degree, we can see that the liquid is going up through the tube. And also you can see the force of cohesion, the cohesive force is found to be less than the adhesive force. So in this case, cohesive force is found to be less than the adhesive force. So adhesive force means the force of attraction between the molecules of the tube and the liquid. Here the glass and the liquid. If that is more, the adhesive force, if it is more, then the sticking of the liquid with the glass is taking place. That means the liquid can wet the glass. And also the leaning over of the liquid is taking place with the acute angle of contact because the adhesive force is small. So these are the points to be noted for the angle of contact being acute or less than 90. Okay. But when the angle of contact is greater than 90, theta greater than 90 degree, we call it as obtuse angle. You can see the capillary depression, or the liquid inside the tube is going down, getting depressed. In this case, cohesive force is more than the adhesive force. That means the liquid molecules are attracted more than the molecules of liquid and the glass. So the liquid is trying to contract to get minimum surface area, and because of that it is going down. And in this case you can see, for the case of mercury taken in a glass, you might have seen that the glass is not getting wet with the mercury, or the mercury is not sticking with the glass. It's because the cohesive force is more. Okay, so such a liquid is not wetting the solid surface, and cohesive force more means the capillary depression is taking place. So these are the points relating to what you call angle of contact in the process of what we call the capillary